What comes to your mind when you hear about softwares like RabbitMQ, Apache Kafka, Kinesis, or any other pub/sub library or framework? What is the one thing that is common amongst them? Let me answer this question for you. All of these softwares can be categorized in terms of their capability of event streaming, message queues, or publish subscribe framework or architecture, which is used for connecting between two different set of systems. Two different set of systems. I know this is not the perfect definition of it, but this is the purpose because of which we make use of these things is to connect between two disconnected systems, two disconnected machines. They communicate via these softwares or libraries or frameworks. And why we make use of all these things? As an example, let's assume that you have created a banking transaction system. Whenever a customer comes to your banking system and does some transaction, the customer receives an SMS after some time. After some time could be, half a second, 1 second to maybe even 10, 15 seconds or a minute. But it doesn't make a difference as long as it's within a time limit. Now, what happens here is that the system which does your transaction is not responsible for sending the SMS to you. The task of sending the SMS is being outsourced to some other entity because the system which is running your transaction system don't want to add additional software load by running a SMS related system or maybe WhatsApp messaging related system because it is not part of its core functionality and it doesn't needs to do in the real time. It may be done in the near real time with some delay, but it need not to be done in real time, nor it's a condition to complete the transaction. Your transaction will be completed whether or not you receive the SMS. And that's why these kind of systems have been developed and made use of. The example I gave was a simple one, but there are many other things. Suppose you don't want to write the logs in the current system itself because writing the log is a CPU and disk intensive job. You want to transfer the logs to somewhere else to be written. What if for any transaction you are transferring the metadata to somewhere else so that it can be checked whether the transaction is suspicious or normal? Okay, so there are multitude of things which we don't want to do in the system where we are doing the actual core work which needs to be completed in real time. We can outsource all those things in some other system, and from there the concept of task queues, asynchronous task queues or distributed task queues or message queues or pub sub architecture comes into picture. Now whatever software I had mentioned in the beginning like Apache Kafka, RabbitMQ, some pub sub architecture, you can make use of all of them for this particular scenario or situations like this. All of them will work perfectly. But here in this particular video, I want to introduce you to something which is pure Python called Celery. And if you want to use Celery, it's not because it's better than other systems out there. It may be not, but it is pure Python. And for most of the scenario for which you have created your Python code, Python system, it can work for you and work for you in the easiest possible way because if you are using Celery, you can make use of Python ecosystem. You don't need to learn a separate programming language to effectively use a particular system or learn a different kind of construct of using a particular system. And that's why Celery may be an option for you. I'm not saying that go ahead and make use of the Celery, but I would always recommend you to have a look at it before making a decision. Now, before I go further, let me talk about the current version of Celery, which is 5.3 and it runs on Python 3.8 at the time of recording this video. I request you to look at their website for latest information. So whenever you are going to use Celery, you are going to use three things. Your program where your code is running, the real program, one task queue in which you are going to transfer the things which you do not want to do in your program because of maybe CPU or memory or time overhead. And third is a library implementation using Celery which take things from your task queue and executes the same. So let's go ahead and see in here. For this particular video, I'm gonna use RabbitMQ as a task queue because it's the simplest one. We can also use something else like Redis, but that is something we are gonna see in later videos. Let's use RabbitMQ for simplicity purpose, and not only for simplicity purpose, for most of the work, as far as I have experienced, it works seamlessly. So let's go ahead and make use of that. So first, what I will do is that I'll create the instance of RabbitMQ using Docker so that my RabbitMQ is up and running. Let me wait. It is running now. Let me go ahead and check this by using localhost and port number. The username password by default is guest and guest. You should change your password if you're making production use of it. So this is my RabbitMQ up and running, working. Now I need to create a Celery program using the Celery library, which can take my task from this particular task queue and executes on the same. So what I did is that I have created a small program. You can see on your screen right now. What I did is that I have imported Celery from Celery, and I'm creating an app using the name of the module. My file name is the module over here, and a broker which is PyAMQP. AMQP is Advanced Message Queuing Protocol. Py means Python, and by default it will make use of the RabbitMQ in the port number that is being mentioned. And now what I did over here is that I have created a task called task queue. Sorry for not following the Python coding convention like task underscore queue, all small. But just for the simplicity purpose, I wanted to create a different function than the next function in a different way. So I've created a task queue saying that the message that is received in this particular task queue is this. So it's as simple as that. You don't need to do anything else, and Celery will take care of pretty much everything. Now I forgot to tell you that you need to install this Celery. It's not coming as part of the Python. You need to install it separately. Okay. So this is my simple Celery code, and I have created another client. Client here is my main program, the program which was working, right? I don't want to execute the task over there. Okay. So what I did is that I said from Celery main, import the function task queue, and I'm calling task queue first task of the Celery. Now what I will do is that this Celery will be up and running in the background in a different machine. Right now it's running on my machine, but in reality it will be running on a different machine. So let me go ahead and start the Celery. Now what I'm trying to do here is that I am creating Celery by using this particular command. What I'm saying is that Celery -a, cell main is the same module name, worker log label as info. I'm going to talk about worker in a moment. Let's see what happens right now. Now my Celery is started. Okay, it's actually running on my system. Now let me go back here and run this particular client. Now, when I'm running this client, look what is happening. The task queue first task for Celery is printed there, which means it is not calling Celery because I don't want to execute this particular function here. The program should not be executed here. It should be executed in my Celery node, and the print should be coming over here, right? To invoke Celery, you need to call the function in a different way, saying that task.delay. This is the way you are making sure that the call of this function goes to RabbitMQ, and from RabbitMQ Celery will pick it up and executes the same. Remember, you do not want this particular function to be executed here because it might take some time, right? So now if you go ahead and run this, you can see there is no printout over here, and if you go to Celery, you can see task queue, first task of the Celery, which means we have successfully transferred the execution of this particular function from this particular place, this particular process, to some other process that is running. And this is the idea behind task queues. Now, just to verify that, let me stop this Celery for a moment. And what I'm going to do is that in the Celery function, let me add some sleep. Time.sleep, let's say 5 seconds. And after that, I'm gonna start this Celery once again. Okay, now when I'm gonna run this particular client, you can see that the client returns immediately. The client execution is completed, but this particular Celery part after 5 seconds, which means when you are running the Celery, it is not impacting the execution of the process or the system from where it was triggered. And this is what we wanted. Now, let me talk about the most important aspect of Celery, which is, something everyone must know and must understand. Okay. So let me close this Celery over here. And in the Celery main, let me add one more, task. I'll say app dot task. I'll create another function saying that write, log. And let me just print it over here. Writing logs. Format. Okay. So I have created another task. Now look at that. The first task sleeps for 5 seconds, and there is another task over here. And let me, call this write log task also from, from my client. The logs are here, just so that we can see it. Now let me start the Celery again. Let me clear it. Start my Celery. Now, when I am running this particular client, what will happen? Now, this task queue.delay, it sleeps for 5 seconds. What will happen? What do you think? Will it sleep for 5 seconds and then this write log will be printed? Let's go ahead and see. The client will, close immediately. The client is done. Sorry, I need to include over here. There is one more mistake. If I want to call Celery, I'll have to say delay. Why delay? It's an indication to say that I am intending this for my RabbitMQ so that Celery can pick it up. Now you can see that this function will terminate immediately. But in here you can see that the logs are here written first. And this particular task queue, first task of the Celery, what is happening? Are you getting something? This is very interesting. Now, Python has a global interpreter lock, which means only one thread can execute at any point of time. Now, I do not want to confuse you with, global interpreter lock. Let me talk about Celery. What happens that whenever you create an instance of Celery, it creates the instance of processes equivalent to number of cores in your system. Which means if I go ahead and see my htop over here, let me see the htop. And if I'm just searching Celery, you can see that I have 10 core MacBook M1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 instances of Celery is running, which means it is doing parallel processing, which means in a particular machine, if you just create one instance of Celery, which means it will be executed on all the cores in a parallel manner. How amazing, right? You don't need to do anything else, anything for that matter, to be able to make sure that it runs on all the core. And that's why, since it is running in parallel, there was no sleep in this particular function. So this particular function was called earlier, and this was there sleeping for 5 seconds. Now, just to verify that, I can control how many instances of worker will fork how many instances of Celery by using a flag called minus minus concurrency. So in here what I'm doing is that I'm calling minus minus concurrency equal to 1. Let's say I'm saying 1 and I'm creating my Celery over here. If you go ahead and see my htop, you can see only one Celery instance, which is actually looking for the incoming messages from your RabbitMQ. So if I am gonna run this particular code again, you can see that it says that received in message queue, but the sleep will take 5 seconds and only then this second function will be executed. Now if I make concurrency edge 2, you can see that the existing behavior will persist, which means here more than one instance will be there. And if I go ahead and run this particular code, you can see that the logs are here is actually printed, and then task queue is printed. So this is the way you can maintain and manage concurrency. Now the question is, can we have concurrency more than number of cores I have in the system? For example, 20. Well, of course you can. There is no limitation to this. You can have that. But how useful that will be for your system, your work, you need to take a call on that. Okay, because there is no magic number I can tell you. Now, there is one more thing. Why I am telling that Celery is more reliable and it works in a reliable way. For example, assume as of now this Celery is not working, right? I have closed it. But what if I don't know from my system, from my client, which is connecting to Celery, whether Celery is working or not? It may very well be, the network is not there, or the system has crashed or something like that. What will happen if I run this particular code? I am running this twice. Nothing happens at the client end. So you will not get an error if the Celery is not working. What instead will happen is that your RabbitMQ, the queue will have these particular 4 items. You can see that it will be there in the RabbitMQ even if Celery is not running. And when Celery starts, let's use it to, when Celery starts, you can see that those things are processed here whenever Celery starts. And you can see that since there are only 2 concurrent items are there, that's why it took some time. But all of these things are processed once Celery has started, and you can see in RabbitMQ that it's being processed. So in this particular way, you can make sure that things are there, it is not lost. Now the last thing I'm going to talk about, returning the message from the Celery. Now till the time we talked about, we are transferring the execution of function from client to Celery. Now I want to return the return value, like whether the function executed successfully or not. Many times it happens, right, to the client. How this can happen? So to do this, let me close this Celery first. What we need to do is that along with broker, we need to give backend. Backend is the place where the results are stored. Okay, so we'll be using RPC as of now for backend. Okay, so what RPC does is that it uses the protocol to make sure that the return value is received by you. So in here, for example, let me call return saying that Q done. Okay, let me get rid of the sleep. There is no need for it now. And here also logs written. Okay, now let me start Celery. Okay, and in the client, what I will do is that I'll just print the return value, which means I'll say result equal to, and I can print result dot get. And in here also I can just say print dot get. Okay, so if I go ahead and run this particular code, you can see that Q done. Sorry, let me run it again. Don't know what is happening. You can see that Q done, logs done are written over here. So this is the way you can transfer some return value to your calling program. Okay, and in the get function, you can give some timeout, that how much time it needs to wait for the return value to happen. And if you don't give any timeout, if the function is taking time, it is going to wait over here. For example, again, the last example will be, if I go ahead and again say time dot sleep, let's say 5 seconds. Let me start Celery again. And at the client end, what I will do is that I'm going to run it. You can see that it is waiting. It will wait for 5 seconds because get is a blocking call. And after 5 seconds, things will be completed. So this is the basic end-to-end introduction to Celery. I do hope and believe that I explained the concepts to you in the easiest possible way. And you can further explore this particular topic. Anyway, I'm going to create more videos on this particular topic because Celery is interesting. Thank you all. Thanks for watching. We will meet again. Until the next time we meet, good day, goodbye. You take care.